हेलो बच्चों, वेलकम बैक टू दक्षिणा क्लासरूम चैनल। मेरा नाम है सोनल प्रताप और मैं आपको इनऑर्गेनिक केमिस्ट्री पढ़ाता हूँ। इनऑर्गेनिक केमिस्ट्री में अब जो हम करने वाले हैं वो करने वाले हैं एफ ब्लॉक। एफ ब्लॉक की एक इंपॉर्टेंट चीज़ है कि एफ ब्लॉक जो आता है वो नीट में और जेईई मेंस में आता है। एडवांस में एफ ब्लॉक का पार्ट नहीं है। तो एक चीज़ हमें ये चीज़ ध्यान रखनी है कि हमें सिर्फ मेंस और नीट के पर्पज से ही एफ ब्लॉक को प्रिपेयर करना है। कोई भी बच्चा जेईई एडवांस के पर्पज से एफ ब्लॉक को प्रिपेयर ना करे। फर्स्ट एंड द फॉरमोस्ट थिंग। सेकेंड इंपॉर्टेंट बात यह है बेटा कि अगर ये सिर्फ मेंस में और नीट में आता है, विच मींस इट विल ऑलवेज बी बेस्ड ऑन एनसीईआरटी। किस पे बेस्ड होगा ये? एनसीईआरटी, क्योंकि मेंस का सिलेबस एनसीईआरटी बेस्ड होता है और नीट का सिलेबस भी एनसीईआरटी बेस्ड होता है। दोनों ही चीजें एनसीईआरटी बेस्ड है, विच मींस ये एनसीईआरटी से एक भी लाइन ऊपर नहीं पूछेगा। ठीक है, तो आपको ये बात समझ आती है कि फर्स्ट एंड फॉरमोस्ट थिंग कि जो आपका जो एफ ब्लॉक है वो मेंस और नीट में आता है। सेकेंडली, इट इज ऑलवेज एनसीईआरटी बेस्ड। सो एनसीईआरटी से ऊपर एक भी लाइन नहीं हम पढ़ेंगे, ना ही हमें उसके पढ़ने की जरूरत है, क्योंकि कॉस्ट इफेक्टिव रेशियो देखो कि जितना आप एनसीईआरटी से पढ़ते हो अगर उसको ध्यान से पढ़ लो तो उसी में से कहीं ना कहीं से क्वेश्चन बन के आएगा, विच मीन्स दैट विल बी इजी फॉर अस। तो हमें सिर्फ ये करना है कि एनसीईआरटी की एक एक लाइन को पढ़ना है। ठीक है, पहला चीज। अब एनसीईआरटी की सारी मेजर लाइंस, सारे इंपॉर्टेंट कॉन्सेप्ट्स मैं आपको एक बार पढ़ा दूंगा, लेकिन आपका एक फर्ज बनता है, आपका एक कर्तव्य बनता है कि आफ्टर यू हैव डन द चैप्टर, और जब मैं ये लेक्चर खत्म करूं तो आप जरूर एक बार एनसीईआरटी को जरूर रिवाइज करें। दैट विल बी वेरी 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 इंपॉर्टेंट। अगर आपने एक बार एनसीईआरटी को रिवाइज कर दिया तो बहुत आसानी से आपको ये चैप्टर आ जाएगा। और कोशिश करना कि जब आप पेपर देने जाएं उससे एक दो दिन पहले ही या दो तीन दिन कुछ टाइम पहले ही इस चैप्टर को खोलें, एक बार देख लें क्या होता है और आसानी से आपके क्वेश्चन बनना शुरू हो जाएंगे। ठीक है, और ये चीज का ध्यान रखें कि ये चैप्टर की इंपॉर्टेंस इतनी ज्यादा नहीं है, बट क्वेश्चन डेफिनेटली आता है। तो वही चीज कि क्वेश्चन डेफिनेटली आना और इंपॉर्टेंस होना, इंपॉर्टेंस नहीं है लेकिन क्वेश्चन डेफिनेटली आता है, विच मींस ऑटोमेटिकली इंपॉर्टेंस ऑटोमेटिकली थोड़ी सी ज्यादा हो जाती है एज कंपेयर टू मेनी अदर टॉपिक्स। ठीक है, तो इस चीज का आपको ध्यान रखना पड़ेगा। ठीक है, तो यहीं पर इस चीज को समझते हुए सोचते हुए शुरुआत करते हैं कि हम कैसे इसमें करेंगे। ठीक है, चलिए शुरुआत करते हैं। अब जनरल कैरेक्टर्स क्या है इनके जनरल कैरेक्टर्स क्या है कि इन मेटल्स में ये आर हैवी मेटल्स, बहुत हैवी मेटल्स है, एटॉमिक वेट बहुत ज्यादा। दूसरा, हाई मेल्टिंग एंड बॉइलिंग पॉइंट क्या होता है? हमने वैन डर वाल फोर्सेस ऑफ अट्रैक्शन में एक कॉन्सेप्ट पढ़ा था कि वैन डर फोर्स ऑफ अट्रैक्शन डायरेक्टली प्रोपोर्शनल टू मॉलिक्यूलर वेट। पढ़ा था कि नहीं पढ़ा था? ठीक है, तो जितना ज्यादा मॉलिक्यूलर वेट होगा उतना ही ज्यादा मेल्टिंग पॉइंट और बॉइलिंग पॉइंट हो जाएगा, क्योंकि जितना ज्यादा अट्रैक्शन है उतनी ही वो पास में है, जितनी ज्यादा वो पास में है उतना ही उनको सेपरेट करना मुश्किल है। राइट, टू सेपरेट द एटम्स विल बी डिफिकल्ट व्हेन दे आर वेरी क्लोज टू ईच अदर। व्हेनेवर दे आर वेरी क्लोज टू ईच अदर you won't be able to separate them very easily. So to separate atoms will be difficult whenever you have more van der Waals force of attraction. तो वही चीज यहां पर होती है कि क्योंकि यहां पर van der Waals of attraction ज्यादा है तो उसका melting point and boiling point is more. Right? So melting point and boiling point will be more. Next, what is the common oxidation state? +3 is the common oxidation state. +3 is the common oxidation state. So common oxidation state will be +3. Right? Now, total number of F block elements 28. Total number of F block elements 28. Say, right? So there are 28 F block elements, right? Okay. We'll move forward and we'll see number of groups. There are two groups here. One are lanthanides who have 14 elements. Then you have actinides who have 14 elements. So 14 equals to 28. So this justifies our answer. First, now in lanthanides, the lanthanide starts from cerium. It does not start from lanthanum. Lanthanum is a D block element. Lanthanum is a D block element. Remember this. It starts from cerium and ends at lutetium. It starts from cerium and ends at lutetium. So remember this. It starts from cerium and ends at lutetium. Lutetium is atomic number 71 and cerium is atomic number 58. Now, when we talk about actinides, it starts from thorium and ends at lawrencium. It starts from thorium and ends at lawrencium with atomic number starts from atomic number 90 and ends at atomic number 103. This part is clear? This part is clear? Okay. Now, when we talk about inner transition elements, these are also known as inner transition elements. What are inner transition elements? There are three types of shells: ultimate, penultimate, anti-penultimate. Right? Ultimate, penultimate, anti-penultimate. Whenever out of these shells one of the shells is also empty, these blocks are known as inner transition elements. Out of these shells one of the shells is empty, these blocks are known as inner transition elements. So one of them should be empty. or empty or half filled or not completely filled. You can say not incompletely filled. You can say incompletely filled, right? So whenever these out of these three, one is incompletely filled, this is known as inner transition elements or F block elements right? Okay, now move forward. We talk about lanthanide series. Lanthanide series starting element is cerium that we talked about. Cerium is the lanthanide series first element, right? And out of these, promethium, there will be an element named as promethium, which will be synthetic and radioactive. Synthetic and radioactive. Why I'm focusing on these 2 points, synthetic and radioactive? Because in exams sometimes they will ask you, ki out of the following, which of the following lanthanides is synthetic and radioactive? So you should remember, in lanthanides only one element is synthetic and radioactive, and that is promethium. And they will directly ask you this. That which of the following elements in lanthanides is synthetic and radioactive. So remember it, promethium is synthetic and radioactive in lanthanides. Okay, now moving forward. We talk about actinides. Actinides, all elements are radioactive. All the elements are radioactive. So you don't have to worry about radioactivity. All the elements are radioactive. And first element is thorium. So all the elements are reactive. First element is thorium. That is simple. Now, thorium, protactium, and uranium are found in nature. The first three elements, these are the first three elements of the actinide series: thorium, protactium, and uranium. These are found in nature. And rest all of them are synthetic. So from neptunium, so uranium ends at 92. So from neptunium to lawrencium, all of them are synthetic. These are all synthetic, and these are known as transuranic. Transuranic means after uranium. These are known as transuranic, meaning after uranium. Okay, so transuranic actinides after uranium actinides, right? This part is unclear. Okay, these are heavier than uranium. That's what I'm talking about. After, if they're coming after uranium, which means their atomic mass will be more than uranium, so they are heavier than uranium, right? And usually they are derived from uranium. So in nuclear reactors, when you put uranium, there are other compounds that can be formed synthetically. And these are neptunium to lawrencium. All of them can be found synthetically, or all of them can be prepared synthetically from uranium. So therefore, these are derived from uranium. You don't found them. You are not able to find them in nature, but you can prepare them synthetically. And they are all radioactive. So sometimes when a question is asked that out of the following, which one is synthetic and radioactive in actinides, all of them are radioactive, but from neptunium to lawrencium, all of them are synthetic. If they ask you which of the following is naturally occurring, then you have to say thorium, protactium, uranium. And uranium. This point is very important. Right? Okay. Now, moving forward, we talk about lanthanides. So these are the lanthanides, right? Lanthanum. This is not involved in lanthanide series. So you start from cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holium, erbium, thulium, yttrium, and lutetium. These are all the elements. Now you don't have to remember all of them. Which are the important ones? I've marked it with the very important thing. See, lanthanum and cerium, europium and gadolinium, yttrium and lutetium. Right? But still, if you want to remember them or if you want to learn them, then there is a trick. And this is the trick. What is the trick? Selenium, which means cerium, selena, and preeti. I have written it in Hindi. You can do it in English also. Someone can write it in English also. Okay. So selena or preeti. So selenium and praseodymium. Ne dande se N and D neodymium से पम्मी PM, right? प्रोमीथियम, सिम्मी, समैरियम को मारा. फिर वो यूरोप गए. यूरोप मतलब यूरोपियम, गेडोलियम, तब टर्बियम, डायरिया मतलब डिस्प्रोसियम, राइट? हो गया होलियम. अरे अर्बियम, टमाटर, थूलियम, yellow, yttrium, and lutetium, LU. See, I've written blue in LU, right? So Y is yttrium, LU is lutetium. Lu is lutetium. So this is how you can remember these, all the elements, but you don't have to remember all of them, right? That's fine. Okay. Now when we move forward, these are the elements. Now specifically see, selenium, see how it, selenium, why I'm saying selenium I've written like this, so not selenium, cerium. You can see the one electron is entering into 5D also. So remember the electronic configuration. See, these all the elements do not follow the N plus L rule. These do not follow the N plus L rule, right? And when they do not follow the N plus L rule, they have a very randomized electronic configuration. They have a very randomized electronic configuration. So you don't have to remember all the electronic configuration, because examiner also knows that the electronic configuration will not be asked. So what you need to remember? You need to remember specific ones. The cerium one. You need to remember europium and gadolinium one, right? So the europium is 4f7 and 6s2, right? And because this is half filled, this is way more stable. So what happens is, in gadolinium the electron enters into D. So therefore the half filled electronic configuration remains that way only. Then the similar way goes again, ytterbium fully filled, so electron enters into lutetium and the electron enters into 5D. Right? So this is, you need to consider this thing. You need to consider that where the electron is entering. Where the electron is entering, right? Okay, so these three configurations: cerium, europium, gadolinium, ytterbium, and lutetium. You need to remember it, right? Now, when you talk about atomic radii, the atomic radii usually generally decreases from lanthanum to lutetium. From lanthanum to lutetium, the atomic radius generally decreases, right? But there is a change wherein europium, where the size is slightly higher than the natural sizes, other sizes. So you need to remember, it decreases from lanthanum to samarium, then it increases at europium, and then it again decreases from europium to lutetium. Whereas in the case of Ln3+, when the charge is +3, there is a general decrease. There is a general decrease from lanthanum to lutetium, right? So there is a general decrease from lanthanum to lutetium, right? This part is clear. Okay. See, I've written it like this, but they are arranged like this. So it is kind of in one period. It is kind of in one period that these elements are arranged, right? So remember that across the period when you go, the size decreases. So this is the same what is happening. Just that when you have a stable electronic configuration, the size increases, and therefore this is also the case in this, right? Now we'll talk about oxidation state. Now, one thing they can ask from the size is, they'll ask you, sometimes they'll ask you a question, and that is very important question. They'll ask you, you have lanthanum, okay? You have lanthanum, they'll take consider taking dysprosium, okay? They'll take this, and then they'll take ytterbium, okay? They'll take ytterbium, okay? So I'm taking ytterbium. They can take any other element, and they'll ask you which one of the following is more basic in nature. They'll ask you which one of the following is more basic. Okay, more basic in nature. They'll ask you more basic in nature. So how do you answer this? Now, basicity, you know, basicity of an hydroxide depends on the metallic character, right? More the metallic character, more the basicity. You also know this, right? For example, you have lithium hydroxide and you have sodium hydroxide, which is more basic, sodium hydroxide. So basically depends on more the metallic character, and metallic character depends on less IP. Lesser the IP, more easily it will be able to lose the electron, and more easily it will be able to lose the electron, more easily OH will be separated. See, you have XOH. As soon as it loses the electron, it gets into X plus and OH minus, which means lesser the IP, more easily it will be, this bond will be broken. XOH. If this bond is more polarized, then this bond will be broken easily. So how the polarization will take place? More delta En. More delta En, which means more metallic character. This should have less En. X should have less En, and oxygen should have oxygen to general En. Now, how the IP will reduce? How the IP will reduce? As you increase the size, IP reduces. As you increase the size, IP reduces, right? And if the IP reduces, this OH will be easily able to take the electron. So IP will reduce with increasing size. And now you know which of the following. See, all of them are plus 3, plus 3, plus 3. Which of the following has more size? This is lanthanum. This is lanthanum. So, which of the following has the more size? Now, which of the following has more size? The one that is at the top has more size, which means it will easily lose an electron, or it has more metallic character. right? It has more metallic character. So if it has more metallic character, its hydroxide will be more basic. Its hydroxide will be more basic. Or you can say, when you go from left to right, the non-metallic character increases in periodic table. This you have studied that whenever we are going from left to right, the non-metallic character increases. So non-metallic hydroxides are majorly acidic and metallic hydroxides are majorly basic. So if you are talking that this is a slightly non-metallic because it is lying on the right hand side, this is more metallic and this is less metallic, what is happening? This is less metallic and this is more metallic. What is happening? The metallic one will be more basic. So you can say this one is lanthanum is more basic. So sometimes this kind of question will be asked in the paper. So remember these kind of question, right? Okay. Now let's move forward. We'll talk about the oxidation state. The oxidation predominantly is Ln2 plus and Ln3 plus, but sometimes it exists in Ln4 plus, right? Why? Because of the extra stability. Sometimes you can gain extra stability, so you usually stay in Ln4. You can stay in Ln4 plus, which means 4 plus oxidation state. Like cerium. Now cerium, if you see oxidations, its electronic configuration is 4f1. 5d1 6s2. This is the electronic configuration of cerium. When you remove 4 electrons, it becomes an inert gas configuration. It becomes an inert gas configuration. Inert gas configuration means it is stable, quite stable in this form. It is quite stable in this form. So cerium remains in +4 oxidation state, right? Because of the noble gas configuration. But cerium is a very good oxidant, very strong oxidant. It can absorb an electron. It can absorb an electron and get converted into Ce3+. But that process will be a quite slow one. Why? It will be slower because this is stable form. From stable form, it is going to an unstable form. Therefore, it will be a slow process. So it gains an electron and gets converted into Ce3+, but it is quite a slow process. And therefore, it is used as analytical reagent. Why you are using as an analytical reagent? Remember this. Analytical reagent should be something like which reaction takes place at a very normal pace, right? The reaction should not take place very quickly. Reaction बहुत तेज भी नहीं होना चाहिए और reaction बहुत slow भी नहीं होना चाहिए. ऐसा क्यों? क्योंकि बहुत स्लो होगा तो 3-4 दिन तक तुम एनालाइज थोड़ी करते बैठोगे. या रिएक्शन अगर फास्ट हो रहा होगा तो वो स्प्लिट सेकंड में होगा, एनालाइज कैसे करोगे? तो वो रिएक्शन थोड़ा सा कंपैरेटिवली मीडियम पेस पे होना चाहिए. वही ये रिएक्शन है जहां पर C4+ C3+ में बहुत आसानी से कन्वर्ट नहीं होता, थोड़ा स्लो वे में होता है. और अगर स्लो वे में होता है तो हम उस रिएक्शन को एनालाइज कर पाते हैं. देयरफॉर इट इज अ वेरी गुड एनालिटिकल रिएक्शन. Right? Now, you have other elements which exist in +4 oxidation state like praseodymium, right? Neodymium, terbium and dysprosium, right? Dysprosium, right? So these are 4 elements that exist in +4 oxidation state, right? There are few which exist in +2, samarium and europium. So whenever they are in +2, their tendency will be go to +3. So they will oxidize themselves. So they can act as good reducing agent. Right? This part is clear? Okay. Now let's talk about the general characteristics. General characteristics are simple. They are silvery white metals. Hardness increases with the increase in atomic number, with samarium being the hardest, right? Then many trivalent lanthanide ions are colored except La3+ and Lu3+. Why are La3+ and Lu3+ colorless? See, you studied about HOMO and LUMO in your class, right? In coordination. Right? And you see, so that from whenever the electron travels from highest occupied molecular orbital to lowest occupied molecular orbital, what will happen? See, you have HOMO, you have LUMO. Now, electron is present in HOMO, the energy is coming, electron is being excited, and this absorbs a specific energy. So whenever it is absorbing a specific energy, which means it is absorbing a specific wavelength, and if it is absorbing a specific wavelength, it absorbs a specific wavelength और किसी दूसरी wavelength को क्या कर रहा होगा? Emit, क्योंकि जिसको absorb नहीं कर रहा उसको तो emit कर रहा है और वही आपको color दिखता है. वही आपको क्या दिखता है? Color. That color is shown, right? The wavelength that you absorb is the wavelength that remains with you, and the other wavelength or the other energy that is not absorbed is emitted, kind of emitted, and that color is shown by the system. That color is shown by the product or the system, right? तो यहां पर क्या है कि जब भी आपके पास F0, अब देखो यहां पर हमने पढ़ा था D0 और D10 में क्या होता है. D0 और D10 कोई भी कलर शो नहीं करते. किसकी वजह से? क्यों? क्योंकि D0 में इलेक्ट्रॉन ही तो होमो-लुमो ट्रांसफर हो ही नहीं सकता. D10 में फुली फील्ड है तो होमो-लुमो ट्रांसफर अगेन नहीं हो सकता. वही चीज F के साथ होती है कि अगर आपके पास F0 और F14 है, F0 और F14 है तो इन दोनों में फुली फिल्ड है एक, और एक में इलेक्ट्रॉन ही नहीं है, तो होमोलुमो ट्रांजिशन नहीं हो सकता, और होमोलुमो ट्रांजिशन नहीं हो सकता तो कलर शो नहीं करेगा, और कलर शो नहीं करेगा इस वजह से क्या रहेगा, कलरलेस रहेगा, इस वजह से क्या रहेगा, कलरलेस रहेगा। ये बात समझ आती है, बात समझ आती है। चलिए नेक्स्ट क्या बोला गया, एक्सेप्ट La3+ and Ce4+ which is F0 and F14 Yb2+ and Lu3+ all are paramagnetic। ऑब्वियसली बात है, जहां पर 14 हो जाएगा वो डायमैग्नेटिक हो जाएगा, जहां पर 0 हो जाएगा वो भी डायमैग्नेटिक हो जाएगा, उसके बीच में जितने सारे हैं वो सारे के सारे पैरामैग्नेटिक होंगे। अब मैक्सिमम इज नियोडाइमियम। मैक्सिमम नियोडाइमियम कैसे हो गया, हमने तो डी ब्लॉक में पढ़ा था कि जितने अनपेयर्ड इलेक्ट्रॉन्स उतना ज्यादा होना चाहिए, और सबसे ज्यादा तो यूरोपियम में होता है, तो नियोडाइमियम में कैसे हो गया बेटा, यहां पर ना हियर यू टेक 2 स्पिन्स, you take spin quantum number of electron, spin of the electron, also the spin of the orbital, also the spin of the orbital। अब देखो ये चीज तुम्हें बता रहा हूं, लेकिन ये पेपर में कभी नहीं पूछेगी कि तुम्हारे सिलेबस में है नहीं। स्पिन ऑफ एन इलेक्ट्रॉन इज ऑल्सो काउंटेड, स्पिन ऑफ द ऑर्बिटल इज ऑल्सो काउंटेड। तो फॉर्मूला कुछ इस तरह से बनता है इसका मैग्नेटिक मोमेंट का, कि फॉर्मूला क्या है, जी जे अंडर रूट जे प्लस 1, दिस इज द फॉर्मूला, ठीक है, जे प्लस 1, वेयर जी जे रिप्रेजेंट्स 3/2 minus s plus 1 plus 1 l plus 1 by 2j plus 1। दिस इज द फॉर्मूला। नाउ यू डोंट नीड टू रिमेंबर दिस, ये फालतू की बकवास है, कहीं नहीं पूछा जाएगा तुमसे। बस एक चीज याद रखो कि जो मैक्सिमम होगा वो किस में होगा, नियोडाइमियम में होगा, और जो इसमें जो स्पिन होता है वो इलेक्ट्रॉन का स्पिन एंड द ऑर्बिटल स्पिन दोनों कैलकुलेट हो जाए। जबकि जब हम डी ब्लॉक की बात करते हैं तो वहां पर सिर्फ हम इलेक्ट्रॉन के स्पिन की बात करते हैं, वी ओनली टॉक अबाउट द इलेक्ट्रॉन स्पिन इन डी ब्लॉक एलिमेंट्स, वहां पर वी डोंट कंसिडर ऑर्बिटल स्पिन, बट हियर वी कंसिडर ऑर्बिटल स्पिन ऑल्सो एंड ऑल्सो वी कंसिडर इलेक्ट्रॉन स्पिन, बोथ ऑफ देम आर वेरी इंपॉर्टेंट, राइट? ओके, नाउ let's move forward again। lanthanum is a metal, lanthanides are metals, right? So metals की प्रॉपर्टी क्या होती है, metals की प्रॉपर्टी जनरल प्रॉपर्टी होती है खुद को ऑक्सीडाइज करने की, राइट? खुद को ऑक्सीडाइज करने की। अगर ये खुद को ऑक्सीडाइज करेंगे तो किसी ना किसी को रिड्यूस करेंगे, राइट? तो क्या करते हैं, दूसरे को रिड्यूस करते हैं। फॉर एग्जाम्पल एलएन का रिएक्शन HCl से, अब एलएन खुद को क्या करेगा, ऑक्सीडाइज, तो +3 ऑक्सीडेशन स्टेट में भेजेगा, तो किसी ना किसी को रिड्यूस करेगा। अब क्लोरीन को तो रिड्यूस नहीं कर सकता क्योंकि क्लोरीन ऑलरेडी अपनी लोएस्ट ऑक्सीडेशन स्टेट में है -1, तो किसको रिड्यूस करेगा, H को रिड्यूस करके क्या बना देता है, H को रिड्यूस करके H2 गैस बना देता है, साथ में बन जाता है LnCl3, बना जाता है LnCl3। तो सारे रिएक्शन में ये हो रहा है, देखो एलएन ने खुद को ऑक्सीडाइज किया, ऑक्सीजन को रिड्यूस किया, एलएन ने खुद को ऑक्सीडाइज किया, हाइड्रोजन को रिड्यूस किया, एलएन ने खुद को ऑक्सीडाइज किया, ठीक है, और क्लोरीन को रिड्यूस किया, क्लोरीन या X जो भी है, एलएन ने खुद को ऑक्सीडाइज किया, देखो, और हाइड्रोजन को रिड्यूस किया, एलएन ने खुद को ऑक्सीडाइज किया, कार्बन को रिड्यूस किया, एलएन ने खुद को ऑक्सीडाइज किया, नाइट्रोजन को रिड्यूस किया, एलएन ने खुद को ऑक्सीडाइज किया, सल्फर को रिड्यूस किया, ठीक है। सिंपल रिएक्शन है, एलएन खुद को ऑक्सीडाइज कर रहा है और सल्फर रिड्यूस कर रहा है। ध्यान से देखना, तो यहां पर +3 ऑक्सीडेशन स्टेट में ही कर रहा है, तो यहां पर सिंपल सा बन जाता है। बात क्लियर? तो इस तरह से कंपाउंड बनते हैं कि मेटल खुद को ऑक्सीडाइज करता है और दूसरी चीज को क्या कर रहा होता है, रिड्यूस कर रहा होता है। यहां पर एक मेटलॉइड की बात करते हैं, वो है मेटलॉइड नहीं, ये एलॉय की बात करते हैं, जो है मिश मेटल, वेरी इंपॉर्टेंट, यूज्ड इन बुलेट्स, ठीक है, जिसमें लैंथेनाइड का परसेंटेज है 95% और आयरन का है 5%। लैंथेनाइड का कितना परसेंटेज है, 95%, और आयरन का है 5%, ठीक है। तो इस चीज का आपको ध्यान रखना है। चलिए अब बात करें एक्टिनाइड्स की। अब एक्टिनाइड्स आपको सारे याद नहीं करने, देखो याद रखो, एक्टिनियम यहां से शुरू नहीं होता, कहां से शुरू होता है, थोरियम से, थोरियम, प्रोटैक्टियम, यूरेनियम, नेपट्यून से, प्लूटोनियम, प्लूटो से, अमेरिकियम, अमेरिका से, क्यूरियम, मैडम क्यूरी से, बर्किलियम एक सिटी है, ठीक है, कैलिफोर्नियम अगेन एक स्टेट है, ठीक है, आपका ये हो जाएगा आइंस्टीनियम साइंटिस्ट, फर्मियम अगेन, मेंडेलिवियम अगेन साइंटिस्ट, नोबिलियम नोबल, ठीक है, और लॉरेंशियम, ठीक है। तो ये सारे के सारे जो नेम्स हैं ना, ये कहीं ना कहीं से ओरिजिनेट किए, किसी कंट्री से, किसी उससे। अब एक चीज ध्यान रखना कि यहां से नेपट्यून से नीचे तक ये सारे के सारे क्या होते हैं, दीज आर ऑल सिंथेटिक एलिमेंट्स और ट्रांसयूरेनिक एलिमेंट्स, दीज आर ऑल सिंथेटिक एलिमेंट्स और ट्रांसयूरेनिक एलिमेंट्स। ये बात क्लियर है? इनको क्या बोला जाएगा, सिंथेटिक और ट्रांसयूरेनिक एलिमेंट्स बोला जाएगा, ठीक है। तो इस चीज को आपको ध्यान रखना है। अब देखो मैंने आपको क्या बोला था कि वो N+L रूल फॉलो नहीं करते, ध्यान से देखो, कुछ भी उल्टा सीधा हो रहा है, N+L रूल फॉलो ही नहीं हो रहा है। तो यहां पर हम N+L रूल को डिफाइन कर ही नहीं पाते हैं, है ना, we are not able to define N+L rule in this. So what happens here is that what should we do, how should we remember? So you need to remember specific ones, which you should remember this, thorium remember 6d27s2. See, the electron is not entering into F, still it is known as F block element. Then you have protactium 5f2, 6d1, 7s2. Right? These two you should know. Then you should know americium and curium, because americium is similar to europium. Europium in what? You have studied in F block elements. F block elements in lanthanides you study europium, है ना? तो europium and americium are almost similar. Just the difference is that europium is 4f7, 6s2. Europium is 4f7 and 6s2. So you should remember America and Europe, two different continents, two different countries, or two different continents, and then they have similar electronic configurations, right? Just that the N is different, right? Now, curium and gadolinium, these will be similar. Gadolinium, these will be similar. Then you come nobelium and laurentium. So it will be similar to yttrium and lutetium. So you just need to remember these few things which are important, right? You don't need to remember each and everything, right? This part is clear? Okay. Now, also the size m+3 size decreases down the group. So whenever, or decreases across the period. So whenever you are asked that which one will be more basic, so you should know that the size, whichever size is more, it has more metallic character. And if it has more metallic character, then its basicity will be more. Okay. Now we talk about oxidation state. Oxidation state के general oxidation state क्या है? +3. Maximum oxidation state नेपट्यून और प्लूटो की होती है. तो क्या है ये? प्लैनेट के नाम से याद रखना कि नेपट्यून और प्लूटो की सबसे ज्यादा ऑक्सीडेशन स्टेट होती है +7. सबसे ज्यादा ऑक्सीडेशन स्टेट होती है +7. ये डायग्राम क्या है कि ऐसे करके ग्रुप में देखो, यहां से शुरू होता है थोरियम से शुरू होती है और खत्म होती है आपकी लॉरेंशियम तक. तो पहले इंक्रीज करती है, प्लूटो और नेपट्यून तक मैक्सिमम होती है, फिर डिक्रीज करती है. ठीक है ना? मैक्सिमम ऑक्सीडेशन स्टेट की स्टेबिलिटी. ठीक है. जनरल कैरेक्टरिस्टिक्स क्या है? एसिड के साथ रिएक्ट करेगा, आराम से एसिड के साथ रिएक्ट करेगा. तो मान लो आपके पास नेपट्यूनियम है, इट रिएक्ट्स विद एन एसिड HCl. तो व्हाट विल हैपन? It will get oxidized itself. So Neptune will oxidize, consider it getting oxidized to +3 oxidation state. So it will oxidize and form NCl3, and it will do H, making H2 gas. It does not happen similarly with HNO3. Why? Because with HNO3, these metals form a protective layering around it, like this. They form a protective layering around it. And whenever they are forming a protective layering around it, the reaction does not exceed other than that. So because of the formation of protective layering, the reaction does not exceed more, right? So this is what happens in actinides. Other than that, actinides are not important. More important are lanthanides. So we'll just go through all what we have studied once again. So see, what are general characteristics? General characteristics are heavy metals and high melting point and boiling point. General oxidation state is +3 oxidation state with F block elements 28. Lanthanides and actinides can be divided. Lanthanide starts from cerium, ends at lutetium. Actinide starts from thorium, ends at laurentium. The atomic weight is 58 to 71, 90 to 103. This is the atomic weight. Okay? Inner transition elements, you know. Then you have lanthanides. Cerium is first lanthanide, and promethium is the only synthetic and radioactive lanthanide. When you talk about actinides, all of them are radioactive, right? Starts from thorium. Thorium, protactinium, and uranium are only naturally occurring actinides. Other than that, all of the other elements are synthetic, or you can call them transuranic, This part is clear, right? Next, you have the electronic configuration. You know the size decreases when you go from lanthanum to lutetium, but there is a general increase in size at europium. Why? Because it has a stable electronic configuration, therefore its size is much more than rest of them. So therefore it has a greater size. Then they do not follow N+L rule. So sometimes the general tendency is we follow the N+L rule according to the off-Bohr rule, but they do not follow the general N+L rule. So their filling will be different. For example, cerium, electron is entering into 5d. For example, gadolinium, the electron is 5d. Why electron is entering into 5d in gadolinium? Because of stable electronic configuration, right? But when you talk about Ln3+, when you talk about a charge on the metal ion, and when they have charge, +3 charge, the size general is decreasing. The only difference is when the atomic radii we are talking about, where europium has a bigger size than rest of them, right? Now you can remember all the things. The basicity I talked about, very important. Sometimes this question is asked, that basicity is dependent upon the types of size of the element, or you can say the metallic character. More the metallic character, more will be basicity, and metallic character is dependent upon the size. Also it is dependent upon the lesser IP. So if the size is more, the electron can be easily removed from the system, and therefore OH can be easily removed, and when OH can be easily removed, it is more basic, right? This part is clear? Okay. Now moving forward, oxidation state. Oxidation state generally 2 and 3, but sometimes they exist in +4. Which of them are existing in +4? Cerium, the +4 oxidation state. Praseodymium, +4 oxidation state. Then you have neodymium, +4 oxidation state. Terbium, +4 oxidation state. Dysprosium, plus 4 oxidation state. Though these 5 exist in plus 4 oxidation state, where cerium is very important because it is used as an analytical reagent. It can be used as an analytical reagent. That is very important. Then you have samarium and europium with plus 2 and plus 3 oxidation state. And whenever they are existing in plus 2 oxidation state, they are a very good reducing agent. Why? Because they can get converted into plus 3 oxidation state, and therefore they oxidize themselves and reduce something else. Now we talk about general metal characteristics. So silvery soft white metals, usually very hard, and hardness increases with atomic number, with samarium being the hardest. And then you have few elements which do not have show color, that is lanthanum 3+ and deuterium 3+. Why? Because you know that F0 and F14 will not show color. Why they won't show color? Because there will be no homo-lumo transition that we studied in coordination, similar to that. But because of that, the color transition will not take place. Then you have paramagnetic nature. But magnetic moment, remember, the maximum magnetic moment will be of neodymium. Why neodymium? Because in F block elements, we calculate the spin magnetic moment of the electron and the orbital. And both of them are very, very, very important, right? So remember this. In D block, only we calculate spin electronic moment. In F block, we calculate spin electron, spin of the electron, and as well as the orbital. Formula you don't need to remember. It is not in your syllabus. I have just given you as an example, right? Okay. Then we talk about the metals reactions. These are general metal reactions when metal oxidize themselves and reduce the something or the else. So they oxidize themselves and reduce other elements, right? Now we talk about mixed metals. This is lanthanoids, 95% and iron, 95% lanthanides, iron 5%. Just remember the constituents, right? Then you talk about actinides. General tendency is decrease in size. Remember, what do you need to remember? Thorium. You need to remember thorium. Thorium you need to remember. Then you need to remember americium and curium. You need to remember americium and curium. That is very important. Then you remember nobelium and lawrencium, right? That is very important. Also need to remember transuranic elements. After Neptune, after uranium, all of them are transuranic elements, and they are synthetically produced from uranium in nuclear reactors. Also, last, oxidation state general +3. Highest oxidation state goes for Neptune and Pluto, and HCl attacks simple reactions, right? So these are all simple things that we have studied today. Remember this fact, beta, that general tendency is that the question will be asked from NCERT lines, only the NCERT lines. So do read your NCERT after this. I have covered all the points from NCERT, but there is a general tendency that NCERT might be asked, or NCERT's small points will be asked. So do read once, do read NCERT, and I feel that this topic will be clear, and you'll able to solve all the questions related to this topic, because it is a very easy topic. You need to remember few points, and from those points only the question will come. So do remember this electronic configuration of specific elements that I have told you, right? Europium, gadolinium, americium, curium, and nobelium, lawrencium, yttrium, lutetium, right? These 4-5 elements you need to remember the electronic configuration. The rest of them will be easy. The question will come easy, and it won't be very difficult for you to solve these questions, right? So hopefully you have understood today's lecture, and we'll meet you with another lecture next time, and thank you for listening.